Scaling application across multiple instances often requires shared and persistent storage solution that enables seamless data access. Now, this is exactly where Vultr File System comes into play, providing high performance and Virtiofs based shared volume without the complexity of network storage. Hello everyone, I'm Sanskriti Harmuk, a developer relations at Vultr, and today I'm excited to walk you through how to create a shareable storage volume using Vultr File System. In this tech talk, we'll start by exploring what is Vultr File System and how it simplifies the shared storage management. We'll also discuss its key use cases and compatibility with different operating systems. We'll understand its architecture and learn how multiple instances can connect to the same volume effortlessly. Finally, we'll go step by step through the process of deploying a virtual file system and demonstrate how to attach, mount, and perform simultaneous read-write operation to test shared storage in action. So, without any further ado, let's get started. Vultr File System, or in short VFS, is a scalable storage solution. It leverages Virtiofs for seamless shared storage across multiple instances. Unlike traditional network-based storage solution, VFS eliminate networking overhead, making it an efficient way to share files between instances with minimal latency. With VFS, multiple instances can connect to the same volume simultaneously, enabling real-time read and write operations. And on top of all of these, Vultr provides an intuitive management interface which makes it super easy to attach or detach instances as needed. Now that we know what Vultr file system is, to understand where it really fits in, let's consider some key use cases. Whether you're running databases, web apps, or AI/ML workloads, Vultr File System provides a centralized storage solution that multiple instances can access. With Vultr File System, you can easily share files between different cloud instances without setting up network file shares or using third-party transfer tools. Since multiple instances can access same volume, backups are synchronized and happen without disrupting active workloads. Now let's talk about which instances can leverage Vultr File System. Vultr File System is fully compatible with Linux-based instances. Most modern Linux distributions include built-in support for Virtiofs, so you can easily mount shared volumes with minimal configuration. This makes Vultr File System a great choice for application running on Ubuntu, Debian, Alma Linux, or any other Linux distribution present on Vultr. With Windows, it requires an extra step. Windows does not natively support Virtiofs, but you can enable the compatibility by installing additional drivers. Once set up, Windows instance can read or write to shared volume just like Linux instances. Here comes a high-level overview of how Vultr File System works. At the core of this architecture is Virtiofs, which allows fast and direct access to shared storage volume. Instances can mount the shared volume using mount tags, making it accessible like a local directory. Whether you're using Windows, Linux, or a containerized application, this setup ensures high speed and concurrent access to data. Now let's quickly go over why Vultr File System is a solid choice for cloud storage. First, it simplifies data management, meaning you can store all your critical files in one place and can access them from multiple instances. It also enables team collaboration, allowing multiple users to work on the same dataset in real time without dealing with file transfer details. Application scaling become effortless as new instances can be added instantly without worrying about data replication or synchronization. Changes made on one instance are immediately available on others, ensuring real-time data sync. And when it comes to cost efficiency, Vultr File System eliminates the need for provisioning separate storage for each instance. optimizing resource utilization and cutting cost by sharing single storage volume. So this was Vultr File System in a nutshell. So far, we have covered the fundamentals of Vultr File System, including what it is, how it works, its use cases, and compatibility. It's time that we finally see it in action. In this demonstration, Humphrey will guide us through the entire process of setting up and using a shared storage volume with Vultr File System.
Hello there, welcome to this Vultr File System demo. My name is Humphrey Pyre and I am a developer here Vultr. In this particular demo, we shall experiment how you can use a Vultr File System volume as a shared volume with multiple instances. In this particular graphic right here, you can see that we have an Ubuntu instance, a Windows Server instance, and a Debian 12 instance. We shall use this Ubuntu server as a production web server that is running the Nginx web application, with the Windows Server acting as the main development machine or the main development workstation that could be accessed by multiple developers to push applications and code to this particular web server for serving to our public users or on the internet. And the Debian 12 server will function as an image server to actually provide images that are required by this production server to feed on this particular web application. And altogether, these three instances will continuously use this shared volume to ensure continuous resource usage with the same read and write operations without any delays or any network usage between the instances, which makes VFS volumes an awesome subscription you should definitely give a try. And so, to get started, right in the Vultr customer portal, I have already deployed these instances. I have the Windows server right here, and Ubuntu server, and the Debian 12 server, and they all reside in the same location, which is the Vultr New Jersey location, or New York. Right within the Vultr File System page, which you can access by clicking Cloud Storage to File System, you can see that I have a test subscription right here that has a simple Vultr File System volume that I have attached to all these instances, as you can see in the state field right here. For more information on how you can actually create VFS volumes and mount them on these instances after attachment, please refer to our VFS Tech Talk linked to the description of this video, and also visit Vultr Docs for more detailed information on how you can mount Vultr File System volumes on Linux, Windows, and any other workstation that is compatible with the VAT-IOFS protocol. And so, to just experiment with our topology right here and ensure that we can create a shared volume with VFS, let me first of all access my SSH session for the Ubuntu server and the Debian server. And right within my server's SSH session, you can see server 3 is my Debian 12 instance, while server 2 is my Ubuntu 24.04 instance. So let's just check the storage usage right here, and you can see that in this particular output, we have our VFS volume with a size of 20 GB and mounted to this particular directory, which is mount VFS. Let's check for the same on the Debian instance by entering DFH, and you can see that we have the same result right here. You can see the usage is actually 0%, meaning we do not have any files there. So let's just list the files and see this. You can see that our directory is empty, and we can safely use this volume on both the Debian server and the Ubuntu server. And to experiment this further with our third instance, I also have a remote desktop connection with my Windows server. Let's go ahead and access it. You can see that right within my Windows server right here, right under this PC, we have this simple volume right here with our mount tag, which is the VFS volume. So this volume is shared between all three instances, the Ubuntu server, the Debian 12 server, and this Windows server right here. If I'm to open it on the Windows side as well, you can see that the directory is actually empty. And now let's actually use this volume and create a shared volume scenario in which you can continuously use it with multiple instances for the purpose of sharing files and collaborating on multiple projects without any network usage. So let's go ahead and set up our Ubuntu server as the production web server to actually fetch files from this particular directory for serving to our users. To do that, let's just go back into the SSH session for this particular server. I have already installed the Nginx web server in here, and you can see the configuration is okay. And if we are to switch into the Nginx directory, and in particular the sites available directory, And let's try modifying the default file right here by going into the root directive, which you will have to notice immediately within this server block. Currently, it's pointed to the var.html directory, which is the default for most web server installations. For our case, let's change this to our Vultr File System volume path, which is mount VFS. And let's save and close this file just to verify our mount location. It's mount VFS. And now let's restart the Nginx service to actually apply these changes. Now, if we are to access Nginx, it will return a 403 forbidden page because we have no files that are actually available in this particular directory. And if we are to just use curl, you can see that we have a 403 forbidden message. So let's just go ahead and copy this default file that normally resides in the var.html directory. And you can see in the output, it's the index nginx debian.html file. So let's just go ahead and copy it to the mount VFS directory. Now that we have copied this file, let's actually test if we have access to it from the Debian side. So right on the Debian server, let's list the directory again. You can see that we have a new file in here, which is index.html. So we have just created a new shareable file, and it's directly accessible on the Debian server, same as the Windows server. Let's just check on the Windows server if this file is available, and we get to modify it as needed. So right on the Windows side, let's just refresh this file explorer, and you can see that we have the file right here. So this file is accessible in real time by both the Debian server and the Windows server, while it's actually owned by the Ubuntu server. So let's just open this file in my VS Code IDE here. So now that we have it open in VS Code, let's just go ahead and make some slight modifications right here. For instance, let's change the H1 from welcome to Nginx to something more likable, something like greetings from Vultr instead. Now, let's also change this paragraph right here. It looks really verbose, so let's just change it as well and just give it a cool tagline like, if you see this page. So this is just a simple paragraph we've written right here. However, we also expect to use our Debian server as an image server to actually provide some images we can throw on this HTML web application. So let's just open a new image tag and let's put in the source as shared volume. Now let's close the image tag. So as you can see, we have modified this application, and let's actually save it and see if we actually have a result. So right within my Edge browser, let's go ahead and copy the IP address of the Ubuntu server. You can see that it's right here on the ENSP1S0 interface and copy it. So let's just go into our Windows server right here and let's paste it instead here to actually see if we can actually access this page. So right now you can see that we have accessed the particular IP address of the Ubuntu server, and we have this simple page as we have modified it. However, we have this simple image here that shows that something is really missing here. So let's just go ahead and add that image from the Debian server. So right in the Debian server right here, let's just list files in the mount directory. You can see that we have the index HTML file right there. In my user home directory right here, I have this file called shared volumes.jpg that is required by the application. So let's just go ahead and copy this file right here to the mount VFS directory. So now that we have copied this image to the mount VFS directory, let's just verify if it can load in our web application by refreshing it right here. So you can see that the image is actually loading now, but it has been sent from the Debian server. So the Debian server did send a file. The Windows server modified the application content, while the Ubuntu server is actively reading any changes to this content and publishing them on this publicly visible website. So let's actually take this a step forward. In my directory here, I have this simple file called script.sh that includes a for loop that operates in a 1 to 40 range to create different files for each iteration. It has a sleep timer of 10, so it will create 40 files with a delay duration of 10 seconds. This will enable us to actually test the continuous privileges to this file, while also testing the read privileges from our Ubuntu server and modification privileges from the Windows server. So let's just go ahead and run this script. And as it runs, let's just go back to our Windows instance right here. Go to File Explorer and see if we have some new files. you can actually see that we have shared volumes, which is the earlier graphic that we actually required to add to this particular web application. And we have file 1, while other files, if we refresh, will be added every after 10 seconds based on our script. So let's just go ahead, as the Debian server writes to this file, let's just go ahead and modify this application even further. Let's just go ahead and add this h1 tag just within the image section. And if we save this application and just go back to the Edge browser and refresh a little bit, we have a new title right here. While if we refresh the directory right here, the Debian server is actively adding new files. And as you can see, we have file 8, and more files depending on the range defined in our script will be added here as needed. So actively, the Ubuntu server is looking for changes or reading all changes in this directory, while the Windows server is actually modifying the application logic in this particular directory, while the Windows server is pushing new files that may be required by this directory, correctly forming a shared volume that is actively being shared by the 3 instances without any network usage. And so, just like that, we have created a shared volume using Vultr File System, in which we are using a Windows server as the main development workstation, the Ubuntu server to serve the application files, and the Debian server as a file or media server to ensure that this entire volume is shared across all instances in real time with the correct read and write privileges for each instance that is actually mounting this particular volume. And so, I hope you enjoyed this demo. If you did, I would like to wish you the best on creating your next shared volume with Vultr File System.
To wrap up, Vultr File System is a powerful, efficient way to create shared storage across your cloud instances. With Virtiofs under the hood, you get high-speed access without network bottleneck, making it perfect for modern applications. If you're ready to try it out, log into your Vultr dashboard, create a file system volume, and start sharing storage across your instances today. Thank you for sticking till the end. Hope to see you in the next one.